First of all, let's get to know about radar. What is radar system? Radar stands for Radio Detection and Ranging System. It is an electromagnetic system used to detect the location and distance of an object from the point where the radar is placed. A radar is an electromagnetic sensor used to notice, track, locate, and identify different objects which are at certain distances. The main objective of radar as compared with infrared and optical sensing devices is to discover faraway targets under difficult climate conditions and determine their distance. Radar has its own transmitter, which is known as a source of illumination for placing targets. Next, we move on to the working principle of radar operation. Radar operation transmits electromagnetic power as well as examines the energy returned back to the target. If the return signals are received again at the position of their source, then an obstacle is in the transmission way. Fundamentals of radar consist of a transmitter that produces an electromagnetic signal which is radiated into space by an antenna. When this signal strikes an object, it gets reflected. The reflected signal is received by the radar antenna, then delivers to the receiver, where it is processed to determine the geographical statistic of the object. To measure the range and location of moving objects, the Doppler effect is used.
Now, we are going to see the real-life application of radar system. Firstly, we have maritime navigation. Since the ocean is so big, it's really hard for us to identify the obstacles in front of the ship. During the night, it was really dark in the ocean, so it's impossible for us to identify what's in front of the ship. To avoid collision with any obstacles or other ship, we use radar system. Radar is used to display the range, bearing, and distance of other surface object on the ocean. For example, other craft, shorelines, buoys, obstacles, and navigational marks. Also used to detect object underneath the ocean. For example, fishermen use radar to detect a school of fish. In an event a plane crashing into the ocean, a radar is also used to detect the black box underneath the ocean. Maritime radar falls under two classifications. The first one, we have X-band. X-band produce a sharper image with better resolution. Secondly, we have S-band. S-band are commonly used during rain of hawk for identification and tracking purposes for objects on the ocean surface.
The distance and velocity of the object and display it on the radar computer.
Next up, I'll be talking about the radar used in the aviation industry. The primary surveillance radar uses a continually rotating antenna mounted on a tower to transmit electromagnetic waves that reflect or backscatter from the surface of the aircraft up to 60 nautical miles from the radar. Whereas the secondary surveillance radar, which is the SSR, uses a second radar beacon antenna attached to the top of the primary radar antenna, which is shown in the image below, to transmit and receive area, aircraft data for barometric altitude, identification code, and emergency conditions. Other than that is the evolution of radar technology, where they introduced the advanced features such as the Mode S and ADS-B, which is the automatic dependent surveillance broadcast. So Mode S is an enhanced version of the SSR, which is the secondary surveillance radar, which offers greater data capacity and increased information exchange capabilities, while the ADS-B takes surveillance to the next level by leveraging onboard chiplet receivers, which means the aircraft that is equipped with the ADS-B will continuously broadcast their precise position, altitude, speed, and other data compared to other radars. Moving on, we have the latest technology in the radar system for aviation, which is the Airport Surveillance Radar 11, which is AS11. That is an integrated primary and secondary system that has been deployed at many terminal and traffic control sites. It actually provides better and enhanced situational awareness for both controllers and the pilots.
So next, I'll be talking about how radar system work in defense. Radar system work by transmitting radio frequency, which is RF, electromagnetic, EM waves towards an area of interest and receiving the waves that bounce back from objects in that area. The radar system must differentiate between these unwanted signals and the signals from the intended target. The signal processor analyze and receive data to extract useful information about the target. So next, I'll be talking about the system, how it works in defense of radar system. So first is transmission. The radar transmitter generates EM waves. Second is propagation. These waves travel through the atmosphere to the target. So third is reflection. The wave hit the target and induce electrical currents on its surface, which cause the target to radiate the wave. So fourth is reception. The reflected wave travels back to the radar, where the received antenna captures them. So the last one is how the component that works in the defense radar system, which is transmitter generates the EM waves, antenna sends the wave into the atmosphere and receive the reflected waves, transmit or receive, which is quality over R device, connects the transmitter and receiver to the antenna and protects the receiver from the high power of transmitted signal. So the last one is receiver, amplifies and processes the received signals, converting them from RF to intermediate frequency, which is IF, and then to digital data if digital data processing is used.
Moving on to weather forecasting, so here's a little introduction regarding weather radar. First of all, it is referred to as Doppler weather radar because it uses electromagnetic energy pulses to search for its precipitation, as well as measuring its velocity and intensity and identify the kind of precipitation such as hail, snow, rain, and etc. Next, we have types of weather radar. So first is the S-band radar, which is built for the longest range as well as the capability of going to heavy storms. Second, we have the C-band radar, which is used for many satellite communications transmission. Third is X-band radar, which is capable of identifying and detecting precipitation particles. Last but not least, we have NextRad, which is designed for monitoring and forecasting weather patterns across the country. So how does weather radar works? First, the energy pulses is being issued into the atmosphere using a solid state or a Q transmitter. So these energy pulses is being referred to as radar beams. This concentrated beam will emanate from an antenna, which is known as a radar dish. Next, if it reflects off the precipitation, such as rain or hail, then the radar beam will then return to the weather disk, where the data is being processed into different parameters. Hence, it allows to access and comprehend the kind of weather that is happening 100 kilometers away from the radar. On the other hand, meteorologists can estimate the distance of an approaching storm and the amount of precipitation by measuring the strength and the speed of the pulse that returns to the weather radar location. Thus, it is possible to identify the kind of precipitation, its velocity, and its turbulence.
Now, I will be presenting about traffic controls. Traffic control system use sensors to identify when vehicles are present at certain locations. Several types of circumstances, including the number of cars passing through an area and your speed, can be measured and tracked with the use of sensors. In many different traffic controls and monitoring situations, such as ramp metering, motorway management, traffic signal control, toll road monitoring, and more, sensors are employed. Firstly, induction loop are the primary, dependable, and most widely used type of traffic light sensors. Coils of wire called induction loops are buried in the pavement to sense variations in inductance. The sensor circuitry uses these changes in inductance to generate signals. Next, microwave sensors use electromagnetic radiation. Microwave technology is less susceptible to disruption from extremely high to low temperature and need less maintenance and installation than inductive loop sensors. Lastly, video sensors can identify when a car, a bicycle, and even a person has entered a particular zone in the camera's detection map by combining hardware and software. After that, a signal is transmitted to the traffic light so that it changes to the proper signal.
In conclusion, radar is a system that uses electromagnetic echoes to detect, locate, and also measure the distance of an object. Radar gets the name in the late 1880s from the experimental work of Heinrich Hertz. Radar is used today in identification and monitoring of artificial satellites in Earth orbit, as a navigational aid for aeroplanes and marine vessels, and many more.